Hello and welcome to this DCD Talks on driving efficient water usage through closed-loop cooling. My name is Kat Sullivan. I'm Head of Channels for Compute here at DCD and SDX Central. It is my pleasure to introduce Tuan Hoang, Head of Cooling Technology and Product Development at Schneider Electric. Hello Tuan, how are you today?
Great, Kate. Thanks for having me here.
Thank you so much for joining us. I mean, it's a big week here at DCD, and it's such a pleasure to actually take a step back, look over the next 15 minutes at what's happening in this space in particular. Before we get started, for our audience, Tuan, can you tell us a bit more about yourself and your role, please?
Yes, so my name is Tuan Hoang. I lead the product development and also the innovation team for Schneider Electric and the cooling business in general with liquid cooling for AI data centers as our focus.
Wonderful. Look, Tuan, you've got a lot of experience in this field, so let's start with water consumption. This has become one of the most discussed aspects of data center growth thus far. So from your perspective, why is this conversation becoming so important, and how can the industry address public concerns around water usage? If we start there, and then maybe we can look at some proactive steps as well.
I think water usage for cooling has been around. It's been leveraged for decades to really provide efficient cooling. But that has shifted, and AI and accelerated compute has really brought it to the forefront of what resources are actually being used to support what our evolution, our industry is providing. So from an efficiency and usage standpoint, I think for the general public and also for the industry in general, is just being to understand what it is, what does water usage mean, how much are we consuming, what are we using it for, and what can it achieve, and how do new technologies and new compute workload contribute to reducing the reliance on water consumption and on energy consumption. And that balance needs to be taken into account as we look at where data centers are being located, what resources are consumed, how efficient they are, and then also how do operators manage and maintain that. And also, I think for the general public, transparency and data-driven decision-making should be more relevant. And I think the industry is demanding that from everyone in the ecosystem, from the operators to the designers to the equipment manufacturers, and also the deployment and the municipalities, and where water is actually coming from.
Well, let's maybe expand on that aspect a little bit, because we are seeing a lot of public concern around water usage. So you've already talked about transparency. I think that's a really important topic and aspect of this conversation. But let's talk about some of the key steps that the industry is actually taking towards addressing this concern.
Yeah, so the decision around how to cool a data center have really two main aspects to the decision making: where the climate that you are operating in, but also the design conditions that you need to operate at, because those two contribute to what type of technologies you need to cool the data center, but also contributes to what the energy and water consumption may be for that location. So, for instance, water usage for cooling has been around for a long time. You have cooling towers, you have evaporative cooling, where water is consumed to remove the heat without leveraging mechanical cooling, which allows for lower energy consumption. But as mechanical cooling equipment becomes more and more efficient, it closes that gap between water usage, the balance between water usage and energy efficiency. And also the set point is really important. When we're cooling data centers or providing chilled water, for instance, at 15 degrees Celsius, as we move up the design condition to 20 to 25 to even 30 degrees Celsius, it allows us to operate the data center and have more economization hours, basically free cooling, where you're not consuming water and you're not spending energy on mechanical cooling. That really changes the percentage and the ratio between economization versus
Mm.
mechanical water consumption. So basically, the more hours you have where you're just rejecting heat from the dry coolers or radiators, the less energy you consume. But as we're able to raise the temperature, there are more hours of operation that you can leverage that, which means AI workloads tend to allow us to raise the temperature much higher than traditional data centers that leverage airside cooling. So liquid cooled servers and data centers actually allow us to raise the temperature so that we can consume less energy. And if water is chosen to remove the heat, we actually can reduce that. So we have seen that between traditional data centers that are air cooled with CPU normal workloads versus AI workloads where water cooled servers are required, you can see by changing the set point up to the warmer water temperature allows you to reduce, even if you're using water as a evaporative mode, you can save 40 to 60% on water consumption, but it's just by raising the temperature of the cooling loop, which AI allows you to do that.
Mm. It's really interesting, and I'm very aware we're almost halfway through our conversation here, and I want to take a moment, almost step back and look at closed loop cooling. We've already spoken about this being highlighted as one of the best ways to reduce water consumption. So maybe walk us through how these systems work, but also why. I guess why can they be more water efficient than other cooling approaches?
And so when you do closed loop cooling solution, this allows you to use dry coolers so that you
Mm-hmm.
have economization where you're not exposing the coolant to the atmosphere, and you don't have to evaporate the water. So you can operate the cooling system dry, even if it's needed, even if evaporative cooling is needed, but also allows you to do trim with mechanical cooling. So the closed loop system allows you to balance and switch between modes very quickly without exposing it to the atmosphere. And then, which allow by being closed loop, when the conditions are right, you consume zero water because you're operating in a dry mode, or when temperatures are exceeding what the free cooling or economization can do, you can then turn on just the minimum amount of water to evaporate and cool and provide and bring the temperature back down. But it also allows you to quickly also use mechanical cooling if you choose to avoid water consumption altogether. So closed loop really allows you to manage and maximize your operation, but also reduce and mitigate the risk of exposing your critical cooling to the atmosphere.
It's interesting. You just said when the conditions are right. And I think this is where one of the most common assumptions is that advanced cooling strategies only work in certain climates. Can you talk us through how broadly can closed loop systems be deployed, and what have you learned about their effectiveness across different regions?
I think the cooler the environment, of course you get more benefit, but then you're not just isolated to cooler environments. Even in moderate environments, if you can raise the temperature and design the set point and maximize what the AI servers can do, the servers can take coolant at 45 degrees C, which is much higher than ambient condition in most locations, which means you can manage the dry cooler or the economization mode much longer. And then you're only managing the few hours of a day during the warmest period of the year where you have to use either water evaporation for cooling or mechanical. And this changes the ratio between decision between water usage and mechanical cooling, is that by raising that temperature, you're minimizing both, and the decision and economy of saving energy versus water consumption become very narrow, especially as cooling equipment become even more efficient than they were even 10 years ago.
Mm. So, what are some of the ways that Schneider Electric, in particular, is enabling data centers to reduce their water usage?
So we provide a cooling solution that look at the entire end to end, right, from the servers all the way out to the environment, and we really focus our solution on bringing options for the customer where water can be completely avoided for consumption while maximizing and increasing the efficiency of the units. But this allows us to really manage the and take advantage of the warmer water. We're developing high efficiency air cooled chillers that operate at warmer temperatures, which allows us to be extremely efficient while avoiding energy water consumption. But as operators can do today, is review where you are with your customers, what your commitments are, and look at the workload. Can you start increasing the set points of your data center? Because every degree that you increase directly results in an either decrease in energy consumption or water consumption if that's the type of system you have in place.
Mm. It's good that you introduced sort of what people should be paying attention to. Is there anything in particular that operators are currently not doing that may be one of the first steps that they should be looking at in order to move towards water usage reduction?
I think in general we have to look at how do we monitor and be aware of the environment and the systems that are actually cooling our data centers. Overcooling it can be safe, but we're not in an age where we have that luxury to do that. So really paying attention, have the awareness and the telemetry in the system so that you can really operate and increase your design and set point while also managing your risk. Because over provisioning and having a too low set point have drastic consequences on how much water or how much energy that you consume, or basically resources that are needed to operate a data center.
Brilliant. Tuan, before we go, we're talking about driving efficient water usage through closed loop cooling. What are your final takeaways? What do you want our audience to take away from this discussion? To tell me your final thoughts before we go.
Yeah, I think be aware of what the servers or the IT equipment can do, and remove the people, because again, at the end of the day, you're serving the IT equipment. So you look at what it can maintain and where it's safe to operate versus any legacy operating condition or design intent that was there. Secondly, just be aware of what the consumption is and what options there are and what technologies are coming, because the industry as a whole is bringing options and more efficient technology to data centers to provide designers, owners, and operators to really be able to make decisions that meets their needs on resource management and also resource consumption.
So think about the facility, think about what you need, and then look at the actual water usage. I think that's a really great place to pause this conversation. Tuan, thank you so much for taking the time to speak with me, and to our viewers watching, thank you so much for watching. If you missed anything, you can go back and rewatch this interview. You can also find more DCD talks on our website, but for now, that is all we have time for. So thank you so much, and goodbye.